Hello again, this is Michael Hicks with your Business Administration 602 Fundamentals of Economics and Statistics. This is our first content lecture. We're going to talk about data types and just go through some terms and some pictures of data so that you're familiar with it. The reason for going through what would seem to be a fundamental portion of the data analysis is to give you common terms to work with. The way we analyze data, what we find that is important or not in data is dependent upon the nature of the data itself. So we need to make sure that we're not misusing that as we move along. So we'll get right into it. Data is some representation of nature. It's typically numeric, but it could be qualitative. Numeric data could be the number of people in a household, the stock price of a company. And then qualitative data is usually something that's descriptive. And different disciplines will use, well, all disciplines will use some combination of these. More typically, numeric data is used in economics, and in finance and accounting. Qualitative data more likely in management or marketing. And then there's things that are in between. So maybe a picture that's being analyzed, maybe qualitative data, but it may have some numeric characteristics, number of pixels, number of colors, and so we probably won't spend a lot of time with qualitative data, but it's as you learn about the type, you'll see that they're often combined. So you hear a politician talking about a decline in the unemployment rate, they'll then immediately start talking about a new job that Mary Jones got, and how important that is to feeding her family, giving her a sense of self-worth. Those are the combination of both numeric and qualitative data. So they're very powerful tools. I'm not going to be dismissive of qualitative data, but this is a class really about numeric data. Numeric data can really take two forms, continuous or discrete. A continuous variable is across some range. And so the range could be unemployment rate from month to month for the US. It could be the height of individuals in a city. And so these aren't continuous in the sense that they range from negative infinity to positive infinity, but they can vary fully across the range that they're measured in. That's a continuous variable. We treat variables like this mathematically as if they are continuous, which means we can use calculus on them fairly easily. Discrete variables are different. Discrete variables would describe characteristics. So are you white? Are you male? Are you married? Do you have a bachelor's degree? Those are discrete variables. They could be categories in a survey. They could be observed variable. And sometimes we can, discrete variables are also, we work to make them continuous. There's a great example of this that in a federal data set where instead of simply asking about race, respondents were physically viewed and the surveyor estimated a skin tone to them. That those are very useful in racism studies. And so in most of the categories we're going to talk about, we'll want to know, why you have these categories, and what they do, what they tell you are different than continuous variables and need to be treated differently in analysis. And among these types of variables, there's cross-sectional data, which describes data on a particular location, a particular county at a particular time and place. So population in 2010 in each one of the US 3,144 counties would be cross-sectional data. A time series data would be population in one county from, say, 1970 to 2020. So cross-sectional data compares between units, stock price at closing on Friday, the 21st of August, 2020, for every country on the Dow Jones Industrial Average. That's a cross-sectional variable. The time series variable would be that stock price every 5 minutes for the past 2 weeks. And then there's a third type, which are called panel data or cross-sectional time series data. and these track individual units across time. There's also longitudinal data, which is very similar to cross-sectional data, but the start and end dates could be different. So, for example, a panel data might describe the average student GPA in Ball State each year by major for the past 20 years. Longitudinal data would study each individual student over the past 20 years, not the average. And so we're tracking individual performance from year to year. And some students are going to be here 1 year, some 5 or 7 years, and that's longitudinal data. We won't discuss that very much in this class, but it will matter in later classes in your MBA program. So let's just go through some examples of these. This is a continuous variable. It's a initial jobless claims, weekly, seasonally adjusted by the Bureau of Labor Statistics. It is reported weekly back to January 1967 all the way through August of 2020, which is the first time we're taping this. And so this is a continuous variable because it's tracked over time. And it can vary down to the lowest level that we would measure. We round this up to the thousandths, but it can take any value rounded to the thousandths. So we consider that a continuous variable, so economists would be comfortable doing calculus if we need be on this. All data collection is sort of ugly, so we're making some assumptions about frequency and quality of the data. We'll talk more about that when we get down the road. And that's an issue also for later classes. A discrete variable is one where there's comparative data. So for example, in this is results from select results from a survey we just completed with the Indiana's municipal and county government. So we have the county FIPS code, which is a federal geographic designator for each place in the country. This county FIPS is preceded by a state FIPS. Ours in Indiana is 18. So DeKalb County would be 1833, Kosciuszko 1885, Whitley 18183. And then we ask them, what type of government are you in? Are you a city or a town or other? And if it's an other, it's blank. So it could be a county commissioner or someone from a special district like a redevelopment or sanitary district or a township. Those are categorical variables or discrete variables. So it doesn't, we could make them 0, 1, and those are useful for some purposes, but that 0, 1 doesn't have any meaning. There's one's not better than 0. You could swap the 0, 1. So for example, if we wanted to see what the population was by city and town, it wouldn't matter what value we gave those two. We could do the statistical comparison. And that value doesn't have any analytical meaning. It's just there to permit analysis to be performed on other portions of it that are correlated with whatever we assign to that. Same thing with the not sure or continue. So a discrete variable in this instance doesn't tell us anything about what these mean. And these were responses to a question that asked, are you going to continue to work from home? And some hadn't started, some weren't sure, some were going to continue. Some were going to expand it. There were some other answers there. Those are discrete variables. This is an example of cross-sectional data. We have the year here. I just copied these from a spreadsheet from some analysis that we're doing. This is a year. The cross-section, this data right here is a FIPS code, the 6085. And so it gives us information about that county, that only one county has a 6085 FIPS code. These are the number of patents between 2000 and 2010 in that county, quite a lot. This is the exposure to imports that occurred in that county. This is the log of patents. This is the log of import exposure plus alpha, which is like a 0.1, just so we're not taking a value of a negative number. And this is what it looks like graph. So the log, natural log of patents over that time period, natural log of import exposure. And this is part of a study we're doing to see whether or not patents were influenced by risk of a firm facing outsourcing. There's some evidence from us and other studies that that was the case. So this is a way you'll display data. And what I would really encourage you to do as a student of business and economics who presumably wants to lead a business or be an important technical um, portion of decision making in a company or an organization is get really good at the graphics here. I've included links to several lectures about the visual display of quantitative information. And I think if you're able to really focus on being good at that, learning your software here, understanding how to do these things, you'll find that will pay off for you. A person who has data can explain data, has command of statistical inference tools, and then can create graphics or be caused to create graphics that are important and useful is very powerful in business. And so I often tell students that work for me in my research center is, the best thing you're learning from us is that you can't get anywhere else is how to display and think about data in a more sophisticated way. These are time series data. These are from the National Association of State Budget Officers. They reflect general, federal, and other funds from Indiana to schools. These are in millions of dollars, right? So they're $7.1 billion in 2010. They're not adjusted for inflation. Then you can see on the right, there's Indiana state total and then the state and local total. And this is what they look like adjusted for inflation on a per student basis. So we're just back to where we're not back to where we were in state and federal spending, but we're back in state. There's other ways to display time series data. This is change in net business investment after the Tax Cut and Jobs Act. These are quarterly data on business investment. We often see quarterly data presented in these columns. It's just another way to make comparisons. And if you look at some of the slides or some of the presentations that I have included in this class, you'll see where it's a particularly valuable way of displaying data. And there are some good visual rules about how you mix and match these types of graphics. Here's a way to compare 2 years across different scenarios. So 2 bar charts of different colors. This is a continuous variable with notation. This is continuing jobless claims. These are the data I showed you, the continuous variable early. I showed you this 10-week period here. You can see how flat it was. It's been fairly flat through most of history up until whatever we're going to call what we're in now. And so this is a very good way of depicting something that has, enormous variability around recessions and then a big outlier, which is where we are now. Here's 2 cross-sectional data, employment at at-risk sectors of the economy during COVID and non-property tax revenue share, just to help illustrate some dual risks to communities, their tax structure. Here are 2 time series data that are compared. These are real change in gross domestic product for both U.S. and Indiana. Give us a good sense of what's happened in the state since 2017, and cumulative employment growth since 2019. This illustrates that Indiana is moving into a recession in 2019 before COVID raised its ugly head to make things worse. So that's really all I have. Again, data is a representation of nature. It's typically numeric, but it can be qualitative. There's a number of ways to turn qualitative data into numeric data for analysis purposes. We usually think about data as being continuous or discrete. And again, continuous variables more likely to be your economists, your finance professors, your ops research. Discrete variables more likely to be management, marketing, those who are dealing with different types of survey data. And then the structure types of data are cross-sectional, right? They compare a single variable across different places or different businesses or different households. So different population at the county level in 1 year across all 3,144 U.S. counties. The per capita wages of each family in Muncie in 2000 survey. Those are cross-sectional data examples. And then time series data are data that cover a single unit over time, the unemployment rate in the United States, the number of people working in Missoula, Montana. Those are time series data, and they're displayed typically in line or bar charts or column charts that are have time as a horizontal axis. And then there's panel data, which are cross-sectional and time series that combine the two. And again, it's important to understand these terms because these types of data require different statistical methods. There are different characteristics about this distribution of these variables. Do they have a bell curve, a normal distribution? Are they a logistic curve? Are they binomial? So everybody's either 0 or 1, like in gender. And so those require some different assumptions. And there's a longitudinal data as well, which tracks individuals instead of units more typically, and they can come and go from the sample, and we still use them. And so that won't be something we do in this course, but it is an alternative. And with that, thank you for this section. Look forward to sharing another with you in just a few minutes.